Okay, so today we're going to continue with this chapter 12. In chapter 12, we're talking about that chi-square distribution, but today we're going to talk about the test for association. This can also have actually a couple names, and another one could be test for independence. So the names look different, but they mean the same thing. And we'll see why in a little while. And then you can call it whatever you want, whichever one. Okay. Okay. So the test for association or test for independence is used to determine if two categorical variables from the same population are associated with each other. So what we're looking at, this is kind of something, I mean, everything's new now, but it's like a new idea that we're going to study two variables. We haven't done that yet. So we're looking at two categorical variables, but they are from the same population. So we're not studying two different groups. We're studying one group. So I know when we're looked at two proportions, we studied two different groups, right? Two different populations. We had two samples and we studied the same variable. So this is different because we have one group. So we'll have one survey, one sample, but we're going to study two variables. Okay. So last class, we looked at those different levels, remember? It's not that. We are not looking at the different levels. We're looking at the different variables. So examples of this could be something like eye color and hair color. Whoops. It's like eye color and hair color. Are they associated? Okay. We could study that. On one group of people, or we could study like gender and if someone plays a sport, right? And these variables could have multiple levels. So something like the gender, we could have male, we could have female, we could have non-binary, right? And then play a sport would be like a yes or no question. So there's my levels, but we're not studying the levels. We're studying those two different um, variables and if they are associated with one another. So let's take a look at what Minitab's going to do behind the scenes for us. We are going to use a new Minitab function here. So the calculation behind the scenes is slightly different from last class, although it is on the same curve. So here, we still have our chi-square. Excuse me, sorry, I could feel that sneeze coming on. And the calculation is going to look the same. It's summation of my observed values minus my expected squared divided by the expected. So the observed I'm going to call them counts. That's my O sub I. And then E sub I, my expected counts. Okay. But E sub I is calculated a little different in this scenario than it was last time. So let's make a note that now E sub I is equal to my row total times the column total divided by the table total. So let's see why we do this and what happens. So here, remember, when we're studying this E sub I, we're looking at the probabilities. I slightly mentioned that last class. So what happens is that we're going to assume independence. And think back. Now, this was a while ago. Think back to step 1. We're in chapter 5. We're looking at pure probability. And if we looked at the probability of A and B, and we're going to multiply that by n, okay? That's what we're doing here. And so E sub I is really, if we're assuming independence here, it's the probability of A times the probability of B times n. And that's what's going on here. Okay? And this is done for each cell in the table. Whoops. We don't have to do this by hand. We don't really even need to think about this. I just like to show you the background because Minitab will do all of this. Okay, we won't be doing any of this by hand. I just like to show you and explain what's going on in the background and the Minitab side. So this is what's different from the last test. So we're going to use a new function in Minitab, and it's going to do all of this for us. Okay. So we have requirements, of course. I went over the requirements last class. I'm going to mention them again. They're the same requirements, right? So the requirements go for the curve, just so you know that. So we have the same assumptions or requirements. We're on the same curve. So let's just make a note, same as last class. And maybe I'll put goodness of fit. So we have that. So what the requirements say that all expected counts must be greater than or equal to 1, right? So remember the counts, that's how many individuals are in a category. So I need to have at least one individual in each category. That's what that's saying. If I don't have 1, then that means I have 0. And that causes a problem. And the other one was no more than 20% of the expected counts can be less than 5. Remember, 5 was considered too small. You'll put that too small. Okay. All right, so that's the background behind the test. Let's take a look at the testing process so we can look at an example together and run through all of this. So the complete test for association. Okay. So we're going to start with the population, of course. So in my population step, what you're going to see, I'm going to cut some things out with this testing process. Makes it a little bit quicker, a little bit shorter for us. Okay. So here we're going to mention the variables. And remember the variables here, we have two variables. So you don't have to say we have two, but I'm just going to say it right here. We have two. So you're going to name variable 1 and variable 2. We do not need to include the unknowns here. So I feel like this is a big deal because it was kind of a big, I mean, it wasn't a big process, but it kind of takes up some time when you have a lot of levels last class. When I say you do not need to, you can if you want. I'm not going to require it. I'm not going to look for it. So you do not need to include the unknown. When I write that, that's for this test specifically, okay? It's not for all tests going forward. And then, of course, we have our goal. Remember, the goal is very important for us. So the goal here is that there is an association between variable 1 and variable 2. Now you will fill those blanks in, right? You will actually list the two variables that you just wrote up here. You won't call them variable 1, variable 2. Now into our method step. We have our null and our alternative, right? So our null hypothesis is that variable 1 and variable 2 are not associated. The other way you can word this, I'm just going to put it in parentheses, they are independent. Remember, we're assuming independence when we're calculating the probabilities. Assume independence. That's our null. Our null is that we're assuming independence. Okay. I'm just going to write that here. We assume independence in the calculation. That is the null. Okay, so when we're assuming independence, so you can word it two different ways. So if you want to talk about the test as association or independence, what's nice about calling this independence is we're used to the null being in equals, right? And when we're doing one proportion, two proportions, we're always used to this null being in equals. And you could say they are independent. That means they're equal, they're independent, right? Like, not that they're equal to one another. I want to say it equals independence, right? When you say are not, you think it does not equal, right? It's not. So if you are in that mode of thinking and you want to keep it with that it is something, then you can call it that they are independent. Okay. Remember, independence, one does not change the probability of another, right? So, or you could call it, they are not associated, whatever you want to call it. Either one works for me. And then the HA, the opposite, right? Variable 1 and variable 2 are associated. Or you could call these that they are not independent. You can even say that these are dependent, right? Something's not independent means it's dependent. You can call it that as well. So there's multiple ways you can kind of write this. And I want you to choose whichever way works for you. Of course, we're going to identify our alpha just like we do any other time and state what curve we're on. So you can say we're on chi-square. And then of course we want to say with degrees of freedom. Now degrees of freedom has changed because we have a whole table because we have two variables, not just one. And degrees of freedom is now equal to R minus 1 times C minus 1, where R and C are just the columns. So I'm going to write that off to the side here. So R is equal to the number of rows, which you could quickly look at and calculate. You don't need to do this by yourself. Anytime we'll do this, and number of columns. Okay. Of course, you can write chi-square out if you want to type it out. You can do that. Let me write it here. Chi-square. Okay, so that's just saying which curve you are on. All right, so that's my method step. So now we're going to get to the sample step. Sample step is going to look exactly the same as last class when I write it here, but it will look different because the Minitab output is going to look different. So we're going to include the Minitab output here, and then we're going to check the requirements. So remember the requirements we have, I'm trying to think where I want to write this here. My expected counts have to be greater than or equal to 1. I'm just going to write it in notation here. And I have to check that no more than 20% of the expected counts is can be less. Oh, I forgot. Less than 5. I was going to use a symbol, but that's okay. Less than 5. Remember, we'll just do a quick statement. It doesn't have to be a whole paragraph there. Just a quick little statement. Okay, so the results. So our results step is going to look very similar to last class. So here we could just make the statement. If you want, you can identify chi-square and degrees of freedom, or you could just jump right in and say the sum of the chi-square contributions is whatever that value is with degrees of freedom equal to the value that's in Minitab. Remember, this is R minus 1 times C minus 1, but you don't need to calculate it. You will be given that. Okay. And then, of course, here we're going to report the p-value. So we dropped the p-value interpretation last class. Same here, we're going to drop it. And we used to, last class, we reported this chi-square and reported degrees of freedom, then wrote the statement. We can just write the statement if you want, or if you want, you can still report the two values and the statement. It's up to you, but these are the two things I'll be looking for in the result step. And then, of course, my conclusion step is the same thing as always. Look how small this is now. So now I'm going to fit 3 steps on one piece of paper, just so you guys notice. So we started out where every step took its own page. So that's like, because we're kind of cutting stuff down, we're getting used to everything. I'm going to ask myself the same question. Is my p-value less than or equal to alpha, right? I can answer it 2 ways. Yes, if I say yes, then we can reject the null, or I can answer it with no. And if it's a no, then I cannot reject my null. Right? I'm going to make my statement. At the alpha percent level of significance, our sample does or does not show support for my goal, right? Nothing new. Does or does not. And then my goal, okay? Plus, like last class, the follow-up, okay? Let's write this here. Plus the follow-up, just like last class, about the greatest contributor to chi-square, my value up here, if we reject the null hypothesis. So remember, this is only if we reject the null. So it's the follow-up statement only when we reject. We're never going to include it if we don't, because if we don't, then we're saying, okay, nothing's different, right, from last class. And if we don't here, then, then we're not going to say, we're going to say that, okay, that these two are not associated, right, if we don't reject the null. Okay. So the conclusion, results, sample, all looks the same. It's really my method and my goals what's changing here, right? And then my variables, I have 2 variables instead of just 1 variable now. Okay. So I want to take a look at an example with you guys, and we'll work through that, and then you guys can work on your daily. This example is a little different. I did not put it into Minitab, and I purposely didn't do that so we can enter it together. So I don't really want to take a whole page up, but I kind of do, I guess. I'm gonna write it on the back. I just want to write out which example we're doing. Example 2 on page 12, I believe, of the type notes. So we're on day 8. Day 8 already. Can't believe it. Day 8 of the type notes. We'll look at example 2. Okay, so I'm going to just look online like we did before. I'm not going to write out the stuff here. We will look at everything typed up together. I'm going to share my screen so we can look at the type notes and the problem that we have in front of us. So here we have example 2. So we're looking at preschool attendance and a pre-algebra achievement. So we're not saying like how often they attend. We're saying if children went to preschool or not, and then what their algebra achievement levels are a little bit later on. So I want to see if it just says specifically before making. So they want to talk about making a recommendation to these. Let's see. 7th graders. Here it is. I knew it was like later on. I just wanted to look. So we looked at a sample of 150 7th graders, and we're looking at their achievement in algebra and if they went to preschool or not, right? So this is the sample that we're studying. When you see this information in a table like this, I feel like it makes it easier for you to figure out what those 2 variables are. So the first thing you need to do when you have a problem like this, we need to know what type of problem this is. Now, this is something, like I mentioned, we're going to work on next week. You're going to have a chance to work on some problems in determining what type of problem it is. So that's like our first step with everything that we're going to do going forward. Determine what kind of data we have, what are we studying, so we know what test to choose, right? It's fine when I say, oh, okay, we're doing association today, but you have to be able to look at it. Like when we get to an exam, you're going to have to look at the problem and say, oh, this is an association, or, oh, wait, this is goodness of fit, right? So goodness of fit's an easy one to pick out from last class because it's always about, oh, this is my breakdown now. Does it match what we saw before? Or does it match something for another area? Or does it match what we, equal distribution? Or does it match something that someone told us it should match, right? This doesn't say anything like this. This just says that we took a sample. So this word right here, oops, just A, is a big deal. A sample. A random sample means we are doing one survey. We're studying one group of people, not multiple groups. So right there is a big deal. And that's telling me, okay, I'm only looking at one sample. So we have two ideas here, right? If you're looking at a random sample, you're either right at this point, we're either studying a one proportion test way back, which was from stat 1, right? We reviewed that already, or this test for association. Because the only other things we've done was goodness of fit last class, and we look, and I could tell it's not that, right? Because I'm not comparing it to another breakdown. And the other thing was two proportions, which was two samples, right? Two populations. So that word A, random sample, is a big deal for me. And so now I have to say, okay, is this a one proportion test? So am I just trying to see what's going on, like what a researcher thinks, right? For just one sample, or am I studying two variables? So a random sample of 150 seventh graders and compared the pre-algebra achievement levels of those who attended preschool and those who did not. Okay, so if achievement is independent, right, there's another key, independence, right, of attending preschool, then the proportions at each level should be equal. So right there, this is two variables, and it's two categorical variables, right? It's achievement level, and we can see it here visually with this table. Achievement level, so it's below, at, or advanced grade level, and it's a preschool or not, right? It's a yes, no here. So we can see I have two levels of this. If someone attended preschool, yes or no. And I have three levels for someone's algebra achievement level. Okay, so right there we can see, all right, we have two different things going on here. So this first answer for this one, it's the test of independence or test of association. It's the same test. It's just, it has two different names. Okay. So now it says, okay, let's take this information we have from this chart and let's get to know the data and create a stacked bar chart. Now, I know for Mac users, it's slightly different, so we'll try to get that figured out as we work through this. But what we're doing here is we can't look at this table and get an idea of what's going on, right? So we can't, it's kind of hard to get a visual just looking at this table. There's kind of too much going on. So that's why we're going to look at a bar chart. Remember, we always look at a chart to get an idea of what's happening based on just some simple information without going through a test quite yet. All right. So what I need to do is I need to take this table and I need to bring this into Minitab. I can't just copy and paste it. It will not work. You can't do that. So I'm going to open up a Minitab file. I'm going to share my Minitab screen. You may follow along with me, or if you want to try it on your own and we'll walk through it together, whichever you'd like to do. But I need to put that table in my Minitab. So I'm just going to go ahead and start typing in here. So here I'm going to say no preschool, and then the one below is yes, preschool. Okay. And up here for my column headers, I have below level, at level, or above, or advanced, whichever one, doesn't matter. It's your work, name it whatever you want. Okay, now I wanna make sure I put the correct quantities, so no preschool with below, I have 29 individuals there. Preschool and below, I have 15 individuals. At level, I have 32 with no preschool and 44 with. Above, I have 9 with no preschool and 21. Right? I can just tell by like saying it out loud and looking at that. Okay, it looks like with preschool, the numbers are better for the at and above than they are, right? So it's better even for the below, right? Because it's less. That's a good thing, I think. Okay, so now we have our table in here. That's all we need to look at. Now I want to just show you something. Look at my column 1. It says C1-T. That means it's a text column. So it means Minitab is recognizing this as just text. If that happened here, so maybe I put below in this little cell here, all of a sudden, once I start typing a word, Minitab's gonna say, oh, this is text, not numbers. And that creates a problem if you're looking to input numbers into something. So make sure that you're very careful with how you start typing this. So if you typed a word in here and then you say, oh, that's wrong, I'm going to fix it with a number, you will still have a T attached to your column header and it will still recognize it as text. You'll have to do it in another column and start over. There's a way to reformat it. I don't know. I just don't do that. I just start over because it's not worth it. It's not worth the hassle of that. It's just worth retyping it. Okay, so let's take a look at a bar chart. So we're going to go to graph and of course down to bar chart. Now I know here if you have a Mac, you have options you have to choose. So my options are just after I click bar chart. So I'm going to click it here and then we'll still have to choose some options, right? So here, if you had a Mac, before you click on anything, it's going to ask you the same thing that I have here. Right? Do you have counts of unique values? Do you have a function or you have a table? Well, we have a table, right? You can see it. So we didn't have a table before. We always had that unique values, but now we have a table. Unique values means raw data, by the way. So we're going to choose values from a table, no matter which, if you're using Mac or if you have the same operating system as I do, you're going to use table here. Okay, so now I have some options. So hopefully that gets past that first obstacle when you have a Mac. And I'm hoping we can figure this out together since I'm not seeing what you see. I'm guessing what you're seeing. Okay, so here my Minitab chart. So let's see what we're going to choose. We're going to choose a stacked bar chart. And I have a two-way table. So see right down here, it says I have a two-way table. And because I have one variable here and a second variable here, that means I have a two-way table. And I'm going to choose to stack mine. So if you have a Mac, I'm not exactly sure what you see here, but hopefully you have an option where it says two-way table. And I don't think your option for stack is at this point like it is for mine.
We have the option for two-way table, but then it says clustered or stacked and then displayed separately. So should we pick the first
stacked.
one?
Yes, do the stack.
Okay.
Yep. Awesome. So that's not that far off. So that's great from what I have. Okay. So here I need to put in my variables, and this is what I have right here. I'm going to put all three of these in. So I'm just going to double click on each of them, below, at, and above, and bring all three of those in. Okay. Now my row labels, I'm going to bring that in, and I'm going to bring in C1. That's my preschool and non-preschool. I didn't label it, so it just says C1. All right. So hopefully we can all bring those in. So now I want to go to my chart options. Now I know if you have a Mac, I don't want to say I know. I don't think you have this, but you might. So here for my chart options, I'm going to show y as a percent. I couldn't figure this out before, and it's okay. You're just gonna have numbers if you don't have this option on your Mac or if we can't find it. But when I choose this, then I can also choose within categories at level 1. It just makes the bars the same height. Now, I think if you have a Mac, you do have an option of making them all one level, possibly. But we can look at that too. And sometimes it's just something we have to kind of play around with. And it's not the end of the world. It's just, this is a visual, right? This isn't even part of a test. Like, I won't ask you for this on an exam. This is just something we're looking at to get a visual. So I clicked OK. So you can see all my bars are the same height. And we can kind of see a little bit of a trend. So let's see, blue is no preschool and red is preschool. So remember, it's below, at, or above. Okay, so I think this is kind of a good indication that preschool is helpful for these 7th grade students with their algebra, right? Because it's increasing, which is a good thing. So when you have preschool, your above looks higher, right? It looks like there's more. I'm going to try to bring this down so I could see more. There we go. So look at the red outweighs the blue, right? In the above and the at even, which is a good thing. And then it's smaller in the below, which is, I think, a good thing. So we're having an idea that, okay, it's a good thing for preschool. So maybe preschool is associated, right, with your achievement level for your algebra achievement level in 7th grade. So maybe it is associated. You see that? Okay, so it's increasing as my levels, right, my below, at, or above are increasing. So that's why I'm going to say, okay, I think it is a good thing. So I'm going to go back to my write-up and we can start our testing process. So this just says to get to know the data and then complete the test. Here. So right here in part A, I just explained why it's independence or association because I have 2 variables. There's my chart. Okay. Sometimes I'll just say, oh, mention something. Just pick something out that you're seeing in your chart. It could be the overall chart, it could be 1 bar, whatever you see. Okay, so here's my population step. So I don't really need to include this. I'm just gonna highlight this. I'm going to, let's change the font to a gray. So we know it's, oh, I didn't wanna do both. I just wanna do 1. So we know that top 1 isn't necessary anymore. Okay, we don't need to mention the objects, but you can. Okay, so we're studying 2 variables and it's the pre-algebra achievement level and the preschool attendance. It's that simple. You don't even have to mention the levels, but you can if you want. Our goal is to find evidence to show that pre-algebra achievement level and preschool attendance are associated, right? That's our goal. We're trying to prove that they are associated. We want to find evidence to say that they are associated with one another. My null, remember my null is always that the 2 variables, so my pre-algebra achievement and preschool attendance are, now here I'm going to write it 2 different ways. So I'm going to say are not associated, because remember that's what my, there we go. I'm just going to write it the 2 different ways so we can see it. I'm going to do it right now with you guys on here. Oops. Okay. And, or they are independent. And my pre-algebra achievement preschool attendance are associated as my HA, or I can write this. What happened? Okay, there we go. That they are not independent, which means, oops, that they are dependent, right? That's another way of writing it. So write it any way you want. You don't have to write it all 3 ways. Just pick a way, okay? I tend to go with the association. So I tend to say that they're not associated and that they are associated. I just like the wording. Choose what you want. My alpha, I don't think it was given to me, so it's going to be 5%. This is not medical. I have a test statistic that's chi-squared. See, it automatically fixes it to to x squared, it's okay. It's not a big deal, but sometimes it's just easier to type chi-square, right? Or if I could type it properly, there we go, chi-square. Sometimes it's just easier. There we go, degrees of freedom, or my number of rows -1 times number of columns -1. We can see what that is from my table, right? So columns are my vertical, so I have 3 columns and I have 2 rows. Okay. It's an easy calculation, but you don't need to do it. And especially right now, we don't need to. Okay, so my sample is going to bring in my mini tab. So let's go to the mini tab and check out that feature. Since this is something new for us, I'm going to go back to my mini tab where I already have my table put in. And let me just check something really quick here. But we have our mini tab and we can start working on our, here we go, just assigning the new captionist. I think we lost the other one. Okay, so we have our chart here, so we want to always go back to the same table. Okay, so what we're going to do is we're going to go back to stats like last class and tables again like last class. And so when we're in stat tables, then you could see the second one down here on my screen, chi-square test for association. So like I mentioned, a lot of times it has the name that we're using in our testing process, so it makes sense. I'm gonna go ahead and click on that one, test for association. Now here, I need to be able to tell Minitab, do I have raw data or do I have summarized in a two-way table? I have it summarized in a two-way table. Remember, raw data will be one column, a whole bunch of information. So I've summarized in a two-way table. Now, if I click down here, my next box, columns containing the table. So these are the columns. These are the vertical columns. This is the below, the at, and above. I'm going to bring them all in. Now here, labels for the tables. Now this is optional, but it's nice because your output will be labeled. So that's why I do it. My rows. So these are the horizontal rows. This is C1, right? Preschool or not. And this is the names for the column category. Now we can do this. I don't have an option, right? Because it's in the gray. So you could type them. I don't think you need to. Because I think it will pull them in here. So I'm going to leave that blank. I'm not going to do anything with that. I need to do one more thing before I click OK. I need to go to this box right here that says statistics. I'm going to check one little box inside here. So if you look all the way down at the bottom, it says each cell's contribution to chi-squared. I need to include it. So it doesn't include it automatically, but I need to click on that and include it. The reason for that is I need that little bit of information if I reject my null for my follow-up statement, right? So I need those numbers for that follow-up statement so I can pick out the greatest contributor. Otherwise, I'm calculating stuff in my head. So if you don't do it, it's okay. But then if you get to the conclusion and it says, and you end up saying, oh, I am rejecting my null, then you need to go back into Minitab and do this part. So it's just easier to do it right now. And then you have it in case you need it. I'm going to click OK and then click OK again. So you're going to see the Minitab probably doesn't really look all that different from last class. You still have this table, but the table is more complicated because I have two variables and then it has your chi-square test. Now, of course, here I'm going to get more information, and it was similar like this with a two proportion test, right? You've got more than one row of information. Just keep in mind here we're using the top row, it's the Pearson. So we're using the Pearson chi-square, we're using the Pearson degrees of freedom, we're using the Pearson p-value. Okay, so you can see here the p-value and degrees of freedom aren't different between the two rows, but my my chi-square is. So it's the Pearson, that top row we're using. All right, so I'm going to bring this into my Word document so we can type some stuff up. I use the send to Word. You probably don't have that option if you have a Mac, and it's okay. I just use it so I can highlight different numbers. I don't expect that in a write-up from you guys. I just do it so you can see where everything is. Or if I want to highlight something specific for myself, I can do that. So it's just an option, but I don't think Mac users have that option. Okay, so let's go back to our type notes and take a look. So you're going to see I brought this over in the way I was just saying, the send to word, and I highlighted a whole bunch of information. I highlighted this because I wanted you to see. So I'm going to bring this down a little bit so we can see. Okay, so look down here, I have my key code. So for my cell content, it says the first number are the counts, right? So the first number are like how many individuals are in that category. And it's not just one category, but it's two, right? Because it's a two-way table. So right here, I can see in the yellow, I have 29, 32, 9, 15. That's what I typed in, right? So you could see below grade level and no preschool, 29 students fell in that category. Do you see it? It's the two together. It's not just one. Then the next number below that, and I have it highlighted in green, so hopefully you guys can see it. Those are my expected counts. So that's the calculation Minitab's doing for us. I gave you that, that calculation, right, in the very beginning of class today. I showed you that calculation that it's doing. That's my expected counts. So remember, the chi-square contribution is it's calculating how far, right, it is. What we observed from what we expected, okay? And that's my chi-square contribution. That's in pink here, like that purpley pink, and that's the third number given, okay? Remember, all of those pink values added up will add up to this chi-square value of 10.529. This is my chi-square I'm reporting in my results step, okay, with my p-value. Okay, so that's the output. I like to color coordinate it so you guys can see, and hopefully that's helpful. You can also see the column totals and row totals. If you have a table given to you and it includes column totals and row totals, I know someone's going to do it because they're not listening, but if you have a table and it gives you this 70, it gives you 80, it gives you 30, it gives you all this, you do not include this in Minitab. What I'm saying is you are not going to type it up into the two-way table in Minitab because it doesn't know its total. It thinks it's part of the data. It thinks now it's another row and column. It thinks it's 70 people are in that. It doesn't realize it's adding them up. You don't need to include it when you put your table into Minitab. Okay, like to mention that it's going to happen. My sample step to finish this off, I need to check my expected values. Remember, this is the green numbers, okay? I need to check those, make sure they're all above 1 and no more than 20% or less than 5. So I need to figure out, okay, what would be 20%? I have 1, 2, 3, 4, 5, 6, right? So I can only have one still because it's 1.2. So I can only have one of those green numbers be less than 5 and still meet my requirements. I look at them, they're all above 5, right? So that means they're all above 1. So I just make the quick statement, all expected values are greater than 1 and none are less than 5. I'm good to go, right? Remember, if you don't check out your requirements, so maybe you had 2 numbers that are less than 5 or something that's less than 1, then you just simply say what you are observing, right? So that you don't meet your requirements, and then you keep going with your test, and then you make a statement attached to your conclusion that you have not met your requirements. In example 1 that happens, so you may want to take a look on your own time at example 1 here up above a couple pages, and you can see where we don't meet the requirements, and you can see what I type up. Okay, so my result step, the sum of the chi-square contributions is 10.529 with 2 degrees of freedom. So you don't need to report those numbers in any other way. You can just state them here, but you're reporting them by stating them in the statement, and that's fine. My p-value is 0.005. So yes, our p-value is less than alpha because 0.005 is less than 0.05. We can reject the null. So at the 5% level of significance, the sample does provide sufficient evidence to say that the achievement in pre-algebra and preschool attendance are associated. So if they are associated, then I need to go back and look at my greatest contributor. So now I'm looking in the pinky purple numbers. I'm looking for the largest one. So it looks like it's this one, 3.491. So it looks like those students who are at below grade level for algebra and they did not attend preschool, right? So what I saw was 29. I only thought 20 would have that, right? So it's greater than what I thought, and that's what's throwing it off. Okay, so you're kind of placing that blame, right? So then you just say the greatest contributor chi-square students who did not attend preschool and are below grade level, and that cell is greater than what we expected. And that's it. So you can see this test is very similar to last class, the write-up and everything. So what you're going to expect to see, it's just now we're studying two variables. So this output is larger, has more numbers, has a lot more meaning to it compared to the last one, because the last one we only had one variable. Any questions on that example or what we're looking at? I'm gonna stop this.